Hello, everyone. Hello. My name's Nicholas Moger. I'm from JP Morgan. And I'm going to talk to you today about our extended story and how we're doing with CDM, our implementation, and digital regulatory reporting. So I've sort of presented on these things a few times, but this one hopefully is a bit different. We've been live now for around 18 months. We're currently implementing Canada with HKMA coming off the tail end of that, and we already have ASIC and MAS. Next year, we're looking to completely migrate all of the existing jurisdictions on, so it's very busy. But right now, I'm looking at where we want to go next. And this presentation is really the culmination of the last couple of months. I've been sort of experimenting life with CDM as a developer, even though I'm not a developer. I wanted to see how easy it was and be able to sort of bridge the gap between myself and the developers on the next stage of our vision. So without further ado, as I say, I'm a product director at JP Morgan, so overall responsible for the vision of where we want to go with CDM and DRR. And as I said, I've spent the last 2 or 3 months experimenting with Rune DSL, CDM, various other things, which I'm going to take you through. Hoping it will allow me to better articulate the next step of that vision. And I think, and I'm going to share that with you with the following goals in mind. So first off, encourage any people who are on the fence about their CDM implementation decision. Help any current or future implementers shape or enhance their SDLC, which is one of the main focus areas for me today. Navigate the setup transformation of the SDLC for leveraging CDM, DRR, and beyond, and help bridge that communication gap between product managers and developers on what the implementation vision looks like. But first, I'm going to explain the extremely wordy title through the medium of animation and a story, which hopefully goes as planned. Okay. You haven't walked into the wrong presentation, so just trust me on this. Okay, so a group of people have a shared problem. They all need to build a widget to perform a specified function, and they've been given a set amount of time to build said widget, and at the end they're going to be judged on the quality of its output. They've all been given basic paper instructions on how to build the widget by hand, and everyone gets to work, eagerly building their widgets individually using the tools available to them. The pressure is on to meet the deadline and pass the quality inspection. The deadline arrives, and almost everyone has completed their widget on time. Let's see how they did. So, expected result, and we've got a few that look close, but none are matching the specification entirely. People start to realize that their widgets don't perform consistently amongst each other and or against the specification. So the group have more work to do. Anyway, fast forward. A few years later, everyone has to build a new widget now from scratch. Version 2. The version 1 widget was a horrible experience. So why is everyone so happy? Because this time around, everyone is given a free 3D printer and digital copies of the widget plans. This is a game changer. No more manual widget building, guaranteed consistent output. Life is good. You've probably seen where I'm going with this now. But with all that spare time people now have, not having to build their widgets, they start to wonder, what else can I produce with this 3D printer? What enhancements can I make to the printer? Now, where we are in JP Morgan at the moment, I classify ourselves as a CDM integrator. We've integrated CDM. So we can use the printer for free. We can leverage pre-existing designs for free. However, embracing true model-driven design and development will empower you and us to enhance the printer, update existing designs, and create your own designs, which is where I want to focus today. And that's the explanation for the wordy title. So I didn't know that this is actually probably a 5-minute challenge for people who know what they're doing, but I had never personally created a build for CDM DRR. The developers do that. It was always something that was actually quite intimidating to someone who hasn't written Java code for about 15 years or run any builds or anything like that. So I wanted to experience what it was like, and this was never meant to be part of the presentation. It's just something I've been doing. So the challenge I set myself Can I set up a developer environment, install the correct prerequisites, clone? I chose the CDM repo, the Common Domain Model. Do the build, which I don't even know if that's the right terminology, but do the build. Execute something in DRR as well, and document the process for any other casual or non-developers. So basically get from there to there. Now, this is going to be very basic for a lot of people, but for me it was sort of a learning experience. So obviously you start with GitHub, you then clone your repo, and you've got your Rosetta source files, and through some magic thing called Maven, there is generated Java, packaged Java, and that's where you've got your starting point for actually being able to use CDM or leverage it. And then you've got your Java runtime, which is obviously putting data into CDM, running DRR, and you've got your projections. Now, I'm not just explaining this because I think people don't know it. This diagram is going to become important in the topics that we're going to discuss. So from an SDLC perspective, these are all of the key steps from getting to the source code through to your actual workflow. Now, I actually wrote a getting started in under 30 minutes thing, which is on my GitHub, which has got some cheat sheets, which are of various things, Rune DSL included, and it's got some scripts to download the exact dependencies that will make it work on Windows or Linux if you just want to get started very quickly. Okay, so now that I've done that in under 30 minutes, I felt like an expert, even though it took me about a day to get all of the dependencies with Node.js and things done. But now you can do it in under 30 minutes. So where do I go now? I've installed the prerequisites, I've run the local build, and I've executed something, as you will see in that on that GitHub. So what do we do now? Well, the most important thing that everyone would have to go through from who's integrating CDM is getting your data into CDM. So you have some choices here. I know that because I know what we've done and I know what we want to do. So a custom data extractor coupled with CDM creation Java functions, or you could leverage Rune/Rosetta directly to model your internal data and ingestion. So for a Java developer, a seasoned Java developer who wants to make progress quickly, the path of least resistance will likely be option one and where they're most comfortable. And that's what currently we've done. So, our data extraction and data modeling from our firm into CDM is essentially custom. And that's what I'm going to call the integrator go-to solution. Let's examine that. So you have your data, whether it be risk management, relational database, or object-based database, and your goal is to get that data into the CDM functions at runtime. This will vary slightly depending on your architecture, but it really boils down to your source data, an extractor, likely some business logic, and then staging data that's ready to go into CDM. Now, in terms of impact of this implementation choice, you're basically implementing at this stage. So you will be building your CDM/DRR build, and you'll have your own internal custom jar, which will integrate at that point. So you've got essentially two build processes that can be combined, but they are separate entities that require each other. Now, what you've created there is a Java level dependency. You won't have any of the sort of visual Rune Rosetta lineage of CDM back to your source data. You won't even have a model of your source data that's visible in Rosetta. For regulatory implementations, you actually may be required to maintain this mapping from source to CDM under some jurisdictions, so it is going to be an overhead that you'll be concerned about. And you may likely have complex business logic within that extraction, which could be considered black box, depending on how it's done. And you will likely need to maintain an intermediary model for the Java staging. Obviously, if you've got a relational database, you're not going to be putting raw database tables straight into Java. It will need to have some sort of intermediary JSON representation or XSD. And then you'll need to integrate your build process, as I said, with CDM DRR. Now, this is by no means the wrong approach. In fact, it's what we did and what we've done up to now. And it will likely be the fastest route to a POC or demo for a Java-centric firm or development team. You're not missing out on any of the CDM functionality with this approach, but the key here is to describe where we want to go, and where, if we were to start again, we would start. So anyway, there is a better way. So the model-driven option, and forgive me, this is not going to go into a lot of detail. I'm skipping some things about how Rune ingest and Rosetta works, but I'm just going to show you an example of what you do high level. I think you talk to the Rosetta guys or the other presentations to see this in a lot more detail. Now, modeling your data in Rune is extremely simple, and that was actually one of the key things I hadn't tried before. So, modeling types, enums, functions, synonyms, and the actual ingestion logic is extremely easy. You can literally write that amount of text on the left, and you will be able to visualize that model on the right straight away without anything else. Now, that's just obviously a trade ID. It's not like an entire firm's data, but it's an extremely simple process. And then what you can see within Rosetta, there's probably a better way to demonstrate this, is when you go to the trade identifier class, which is a CDM class, you can see the relationship between it and your firm data on the top right there. So you've got CDM and your type. And this is all, I might even have been doing this completely wrong, but this is all part of my experimentation with what I've been doing and finding out how easy this actually is. So if you code your your firm data or ingestion data at the Rosetta level, so in Rune DSL level, you've created a Rune level dependency. So what happens then is all the Java code for ingestion can actually be generated. Business logic can be exposed in one place, so rather than it be black box, you can actually write the functions in Rosetta UI. You can master your model there, and you can annotate it extensively and version it within Rosetta. And the data can be ingested very close to its source format without the need or the heavy requirement for an intermediary model. And obviously, if you're using Rosetta UI, which I'll go into a bit more detail in a minute, you can actually integrate ingestion test packs for a full end-to-end experience. At the moment, the ingestion part is while it is linked in an end-to-end flow, we can't test everything all in one place. So yeah, and it's a unified build process. So once the ingest process is understood, and you have a good understanding of Rosetta and Rune DSL, you will eventually, I think, based on my experience, find development to be faster in the long term with this approach than the custom Java, assuming you've got the knowledge of ingest and Rune. For anyone who doesn't believe that I did this, I created a basic project to show how ingestion works, which takes some sample XMLs, runs the creation of a custom trade model, not CDM, completely custom, very basic trade model, has some functions, very basic, some defaulting, and then it outputs projections of those. And you can look at that work on this GitHub. So that's your model-driven option. Now, most of you here, or some of you will at least be looking to use CDM for the purposes of digital regulatory reporting. Now, we've looked at the left-hand side, getting your data into CDM. There's a right-hand side to this as well, which is your regulatory user interface or workflow in general. So all the things that come out of your CDM for DRR flow, you need to do something with them. They need to be submitted to regulators. They might need to go into queues. They might need exception management. They might need control processes where users can edit the fields if in the event of an exception. So all of that is the right-hand side, if you like, of the flow. Now, again, there's two options here. So the option one is your direct projection integration, which is essentially a completely custom jar. Or I'm saying jar, but obviously it could be Python, could be something else. But the integration point is with the outputs themselves. So the JSONs, the XMLs, the ISOs, etc. Now, what would have to happen here is you'd have to write parsers for these formats, whether they be JSON or XML. The data on the projection, if you're looking to create a user interface, might not meet all the requirements for your user interface. So, for example, if you're in a regulatory exception workflow, you've got your ISO 2022 message. The data on that message might not be enough to, sort of instantiate an object on a user interface with all of the right and ancillary information to take it through the workflow, such as the system source or the desk or various other information. Now, you therefore may need to augment that data with from multiple sources, whether that be the CDM objects projections or the ISO projections as well. And you've created another Java level dependency, assuming Java implementation, and you also have to be storing, processing, and augmenting the projection. So what happens if the projection format changes? ISO 2022 could move on to a future schema, which means all of your UI code potentially that's parsing that would need to be rewritten. So there's an option 2. So option 2 would be the model-driven development. Now, this isn't even something I've actually heard anyone talk about as a possibility. It's just something that, through our own implementation, I could see would make sense if it was done this way, which is to essentially author your UI data model and projection requirements in Rune itself. Now, from there, you have access to the full CDM model, and you can obviously model your own firm's data, which we'll be talking about in a minute. And you can create custom projections for exactly the type of, say, XSD that your user interface needs to show, without having the user interface itself be coded from the projections itself. So you can model user interface functions and user interface data objects, if you like, in the Rosetta itself, which would be a huge SDLC maintenance and has huge SDLC maintenance and documentation advantages longer term. You can leverage the built-in CDM functions along with your own. What we found is, out on our implementation, a lot of the things that were being written manually were actually pre-existing Rune functions. You want to display certain trade details, or look what the asset class is of a trade in order to put it in the right bucket in a UI. There's no need to write all this stuff again. You can leverage those functions that already exist. And you can easily combine data from multiple sources. So that's like looking left to right on a CDM DRR implementation, the 2 areas we want to focus and to take things to the next level. So what I've done here is bring this together in sort of what a realistic flow would look like end-to-end with CDM DRR in our future state, which would be having the trade ingested, or our firm's model ingested via Rune, translated into CDM for DRR, and then with other things that I haven't actually mentioned directly, but ref data APIs coming from the CDM object itself rather than being requested or called before the CDM flow, connecting to things like the Gleaf, the ISIN gateway, UPI, and ingesting that directly into the DRR reportable event. And then having our own custom validations, which is something I haven't mentioned, but obviously DRR comes with a whole swathe of validations, but you might want to write your own. You might want to write custom business rules or custom anomaly detection on your reports. You can do that in Rune as well, and have your UI projections that we just spoke about too. So that's almost like an entire end-to-end flow that could be written with very little outside like custom code, apart from your user interface itself, in Rune DSL. Now, what's next? Okay, so your firm model is now mastered in Rune. So what opportunities does this give you? And this is where I'm going to go into some of the big areas for us that I think are going to be valuable. So you've got CDM. I'm calling it CDM for DRR because CDM as a model has moved on to version 6 and version 7 soon. So CDM for DRR is its own version of CDM, which is critical. Now, if you're using CDM for DRR, you might want to, from a developer standpoint, protect this specific flow because it's regulatory, to ensure that there's no regression issues, which I'll explain in a second. So what you could do with your firm model, what can you do with your firm's model being modeled in Rune? So I imagine lots of you here have custom feeds or system-to-system CSVs basically legacy, what they call legacy feeds in the banking world, which you might be in the process of being migrated to some strategic model, or they just might be so old that people are scared to touch them. What you can actually do is, if you're modeling your data in Rune, you can take these legacy feeds and uplift them and model them directly as your own version of the report, like your own DRR, if you like, and bring them into Rune. So what you get then is the visual lineage, the business rules. You get rid of all of these black box legacy procs. And what you'll get is economies of scale. So as you start to migrate feeds, you can start reusing boilerplate functions within Rune to create these reports. And not only that, but having them all in Rosetta means you can catalog them, you can version them, you can master them all in one place, which for the hundreds or perhaps thousands across the firm legacy reports that we have, that would be extremely advantageous. And that doesn't need to involve CDM. Note I'm not actually mentioning CDM here. This is feeds that are so sensitive from a consumer perspective that you don't actually want to adjust the way they work, at least in the short term, because of the risk. But you can uplift the SDLC around them by bringing them into Rune and having them projected from Rune. And you can project obviously in legacy formats as well. And so you're really transforming legacy SDLCs and change management with that. Now, in a normal, I guess, non-CDM world, if you told a developer they had to manage 2 branches of a certain code set or build, there might be concern there. But with CDM, as I say, if you wanted to protect your CDM for DRR flow and have a completely separate instantiation of CDM version 6, it's a lot more simple in terms of managing that through either Rosetta or internally, the overhead of that, and it's much less overhead to do this. And you likely will want to do this because obviously if you're experimenting or contributing to CDM, that means it's going to be newer and newer versions that you want to work with. So let's add to that model a bi-directional projection of CDM, one into version 6, one into your DRR flow, which is protected. And that means you can decouple your critical regulatory CDM use case from other flows. Now, I'm sure there's more than one way to do this. We haven't done it yet, by the way. Maybe you could convert from CDM for DRR into future versions and backwards, but for us, I think it would be more maintainable just to have a completely separate non-regulatory instantiation of CDM as well. So yeah, as I say, some firms will have more than one internal model. They may have a strategic one. They may be using fixed FPML, IBML. You can model all of them in Rune. There's no stopping you having. There's no reason to have one model. What you can then start thinking about is model-to-model translation, which we'll talk about in a second. But usually managing multiple models is also considered a negative within a firm. There's usually pushes to migrate everyone to a single model. What this really does is address some of the drawbacks of having multiple models, because you can, as I say, master them and version them all in one place, and you can start to create relationships between them. And then when it comes to CDM itself, there may be extensions that you want to have in CDM that don't exist. That could be bespoke or proprietary internal data that you don't want to commit back to the community, or it could be something that you believe you can improve upon and you want to commit that back to the industry, which is obviously where we want everyone to go. But there's obviously going to be proprietary, for larger firms, that there's going to be proprietary aspects that they might want to have internally. And it's very straightforward, extremely straightforward and easy to extend the CDM in a build. To speak to Minesh, he'll explain about private extension management. And I've done it myself, and if I can do it, then anyone can do it. And I'm actually shocked on how easy all of this stuff was. My previous presentations have been very theoretical based on what I see coming out, knowing how easy things have become. But this time I can speak confidently because I've actually done it myself. And then obviously you've got your alternate use cases of the one and many growing options there. Okay, so trade management checks. In your firm, you may have APIs in your workflow, whether that's pre-trade or post-trade somewhere, where you need to do pre-trade checks, either regulatory or non-regulatory, or eligibility checks. Now, a lot of you might have an API, the REST API-based checks, where whenever a new check is added, you have to have a new API call or a new API definition with that endpoint. We certainly have things along those lines. What you could do is switch that SDLC on its head. So what you'll find is if you switch to something whereby you project your CDM object to the API endpoint, as long as if they've got the entire CDM, they might be able to code as many checks as they want, and they could obviously author those business rules in Rune and have CDM to CDM integration. But where we're going with this is every time we add another check, it's actually not really, how do I explain this? It might be a different API call, but it's technically from a data perspective not it's coming from the same source data. It just happens to have to be a new REST API call. But if you're sending CDM, as I say, the receiver can write as many checks as they want on that data without you needing to know. And they can, in theory, augment your CDM and send it back to you, in custom eligibility check responses, etc. So it can be game changing if it suits your use case. Now, the next one. So that's what we were calling a CDM-based API. So point-to-point CDM, producer-consumer. Okay, so in terms of where we are at work, where we are at JP Morgan, is the developers know how to run the builds. People are using the Rosetta UI and understand how the rules work, etc. for DRR, but there's a gap, and that gap is understanding how domain-specific languages or Rune can really be leveraged within the firm. And I've touched on some of those things. So as a systems architect, from experience, they might say, what are the risks of creating such large dependencies on a single DSL such as Rune? What if you already have existing DSLs, which some firms may do? And what if a superior one comes along in the future? So first of all, I'm going to quickly, a penny dropped for me, like later than it should have. Probably it was last week, around I do know the difference between Rune DSL and the Common Domain Model, but something occurred to me, which is obviously a DSL or domain-specific language exists to allow for the creation of domain models. CDM is a domain model which has the domain of financial products. Rune DSL is actually a special case because its domain is the creation of domain or meta models. This isn't official. In theory, it sounds like to me, Rune is almost like a meta DSL because its domain is the creation of meta models, and then you have DSL implementations, which is the FINOS Common Domain Model, and the digital regulatory reporting, which is a regulatory domain model which extends the Common Domain Model, both authored using Rune DSL. Now, if you just forget everything I just said, one way of putting it is XML is to FPML what Rune is to CDM. At least that's what made sense to me. Now, why am I saying this? Because a DSL is very different to a compiled language. Now, imagine you as a developer arrive at work one day and your CTO says that Python is no longer supported in your firm and everything must be transitioned to Java. So that would panic most systems architects. So your entire stack is written in Python, millions of lines of code, thousands of Python developers. You need to change your entire ecosystem, runtime behavior, hardware integration layers, all kinds of differences between the two languages in terms of typing, threading, memory models. On the face of it, it's an impossible task, which is unlikely to ever happen. Now, the reason I'm saying this is let's examine the same scenario in the context of a reliance on a single DSL. But before I do, the idea of transitioning from Python to Java is there's no quick solution for that, right? It is my point. But transitioning between DSLs is not the same. So a meta DSL, so let's say Rune DSL, is by nature restrictive in terms of its scope. They exist to define types, attributes, relationships, enumerations, inheritance, and constraints. They're describing something that exists, i.e. they're declarative. They're not having runtime behavior. So mapping between different meta DSLs can actually be automated. And this is a slight technical deviation, which I went down a rabbit hole looking at, using something called abstract syntax. I knew I'd get to do that again. Abstract syntax tree and intermediary representation, which is a very complex way of explaining something very simple, which I'll show you in a second. Now, some of you might have heard of Legend DSL, which is another DSL used by other firms, and some of your firms may use it. And so what I'm talking about here is how would you, in theory, move from one to the other or vice versa. Again, this doesn't exist. It's in somewhat hypothetical, but it's actually reasonably straightforward to achieve. You have your Rune model on the left, at the top left, sorry, and then your AST, which to some extent already exists in Rune. It's how it would be compiled in the first place, which is descriptive, another level up, if you like, describing the data. So instead of having 1.1, it describes what the concept of multiplicity is, what its upper and lower bounds are, etc. And then your neutral intermediate representation is what I want to talk about, which is essentially a representation of the data that is neither left or right, but it is able to not lose any detail from the original source of either side. And then you can go from IR to, say, Legend, for example, to have their representation of the data. So there's no off-the-shelf intermediate representation, at least I'm aware of, between Rune and Legend. That's not the point of this. The point is creating one would be manageable if you had to, or if you already have another DSL that's custom to your firm or proprietary. What I've said at the bottom here is seek out your firm's information architects. They exist, and they'll be very excited to talk about this stuff. But it is critical when it comes to addressing the deep integration of something like Rune DSL within your firm. The key is you're not pigeonholed into using, even if you use CDM for DRR and Rune is, everything is authored in Rune and you've got Rosetta, there's no reason not to have, you can't have other DSLs or other model mappings in there as well across your firm. In fact, it makes sense to have multiple DSLs because they exist to operate within a specific domain. There are some for crypto assets, there are some for quant calculations, etc. So the point is it's very different to a Java to Python problem. It's much more manageable and much more feasible to actually address. In terms of time, what have I got? 32 minutes. Okay. In terms of development environments, Rosetta, we've been using Rosetta heavily, and as I say, where we are now, the standout features of having a Rosetta license are making your SDLC accessible to non-developers, which is obviously what got me down this rabbit hole in the first place. I've only been using Rosetta up until a few months ago. If you take all of these things in mind, we've talked about creating your own models, creating relationships between models, your own function, your own ingestion, your user interface, etc. What Rosetta will give you is a single place to master, version, and model and catalog all of that data. So, considering doing this in a raw Bitbucket or GitHub IDE only place, you don't get any of the visuals that you get in Rosetta. And what I'm trying to say is you can obviously achieve some of these things within like a normal SDLC with a normal IDE, but Rosetta allows you to sort of bring everything together into one place, and it's across tech and non-tech, which is the most critical part. The other thing is that you can do in Rosetta is prototype fixes without requiring a developer to actually create a build themselves. Now, it takes a few hours for us to create a build for network reasons mainly, internally, but we can prototype fixes for DRR or CDM in Rosetta, and within a few minutes seconds actually, be able to run test packs and see the results, which is huge. Obviously, it means product managers, product owners can front run or prototype fixes without wasting developers' time on the actual fix itself. The ingest functionality that I made a point of earlier, you've got the interactive representation of that in Rosetta, and much more. This is not an advert, but what I'm trying to say is that this is a key part of the future of our model-driven SDLC. That's where we want to use it even more. Now, if you do open CDM DRR in a development environment such as VS Code, it looks like, well, it doesn't look very, very appealing. It's because obviously it has no built-in language server protocol to understand what the Rosetta files are. So you just get this sort of white text. But there isn't yet a language server plugin on the Azure Marketplace. However, the Rune DSL repo, during my messing around with all of the code in the last couple of months, had the basic framework for a plugin with a README file that says feel free to extend. So I took the initiative and enhanced that plugin with the goal of publishing it. I'm going to give you the link, but it's not formally published yet. We'll do so in due course. It has some teething issues, so use at your own risk. And for those of you who prefer IntelliJ, as soon as we've got the kinks ironed out in the VS Code version, we can encapsulate that and use LSP4IJ to just use it in IntelliJ as well. This is what it looks like. That's the CDM model that's open. And you can see there are some red items, but I'm sure we can fix those with the help of people who know better than me. But in terms of a language plugin, it works on Windows, Mac, and Linux. The plugin project itself builds from remote sources. It has full linting, IntelliSense, hover, formatting, diagnostics, inlay hints, semantic highlighting, deprecation warnings, real-time Rune to Java code generation, which is disabled by default because it can be a pain. But if you're writing a non-CDM, non-DRR project, and where you're just writing Rosetta code, it will generate the Java for you as you literally type. And it has full GitHub Copilot context enhancements, which is extremely powerful if you want to ask questions around things like DRR or find logic, etc. Now, it also does something which is copy the basic types and annotations from a remote source on startup, so you'll get some messages asking if you want to do certain things. But come and see me after if you need any help with it. Work in progress. I've disabled code actions at the moment. That doesn't work fully. There are some false positives which we need to work on, and we just need to accomplish more testing, essentially. But if anyone does have any development experience with any of this and they want to help out, please let me know. And that's it. Thank you for attending. I hope. Oh, sorry. The link is there, but obviously I'll share that. I'm sure you'll get the slides digitally anyway. But I hope this has given you some ideas and inspiration about where you want to go next with your model-driven development journey. And maybe in 6 months to a year, if I come back to one of these, I can show you what we've actually done. And yeah, that's it.